Hi folks, welcome to day 1 of your extra credit chapter 9 unit. Remember that with this extra credit unit, the biggest piece that's going to be most impactful will probably be the test. But in order to take the test, you do have to do all of these, all of the day's videos, okay? So make sure that you do all of the videos leading up to that test. Starting with this one, so good start. All right, good job. All right, so chapter 9 is all on right triangle trigonometry, all right? And that sounds a little intimidating, right, because it has an official name. But you have all covered right triangle trig when you took geometry class. You probably also covered it back in like pre-algebra and stuff too. So this should be stuff that you've seen before. So what we have here is a right triangle, which just means that there's at least one 90-degree angle. If you remember a few things about right triangles, right, the inside of a triangle, the interior angles, so this angle plus your right angle, all right, always equals 180 degrees. And we'll come back to that later, not today, but later in this unit. All right, so right triangles are super important in regards to like the physical world. Because they come up all the time, and honestly, so do sine and cosine. Anytime that you listen to like any music, anytime that you're working with the vast majority of most things, honestly, like a lot of electronics, like have foundations in sine and cosine waves. So these are a huge part of math, a huge part of physics, and a huge part of the world around us. So that's why it's important to study them and to understand them. So in working with right triangle trig, you're first going to identify some angle theta, all right? And it just looks like a 0 with a line through it. And from this, we can then identify our different side lengths. So we always know that the longest side in a triangle we call the hypotenuse, all right? But there are two other sides to the triangle. And those sides, the names, depend on what angle you're working with, right? So whether the angle is here or whether it's up here. The location of the angle changes the name of the side length. And that's because for the side length that's on the opposite side of theta, we call that the opposite side. I know, very intuitive. And the side length that's right alongside theta, we call the adjacent side. All right. Now let's go over and review some definitions. So if we remember SOHCAHTOA, which you probably learned when you took geometry, you know that the sine is always the opposite over the hypotenuse. Cosine is adjacent over hypotenuse. And tangent is always opposite over adjacent. All right, and opposite is referring to opposite side, adjacent side, hypotenuse is the hypotenuse, all right? These were the three normal trig functions that you learned likely in geometry, all right? But we also have 3 more trig functions. We're gonna start with cosecant. So cosecant, we abbreviate as CSC of theta, all right? Cosecant is 1 over the sine of theta. All right, and so that means that it's the hypotenuse divided by the opposite side. Secant is abbreviated SEC of theta, and that's 1 over cosine. So cosecant goes with sine, and secant goes with cosine. I know that that's a little counterintuitive, and that's why I'm pointing it out. So secant is always 1 over the cosine of theta, so that's the hypotenuse over the adjacent when you're trying to find that in an actual example. And then we have cotangent, which is 1 over tangent. We abbreviate that as COT of theta, and that's the adjacent over the opposite. However, since the tangent of theta is also sine over cosine, cotangent is cosine over sine. All right, so those are your 6 trig identities, or 6 trig functions that you're going to be using throughout this chapter. All right, so it's just fractions. It's really just ratios. Let's go ahead and try out an example. And this example is going to be an interactive one where you're expected to answer questions along the way. So, in working with this example, we have a hypotenuse of unknown length, an angle theta up here, and then we have an adjacent side of 5 and an opposite side of 12. So I'm going to identify opposite and adjacent. All right. Our first step is to find out what the hypotenuse is. And for this, we need the Pythagorean theorem, right? That a squared plus b squared equals c squared. Well, I wrote it in terms of the hypotenuse. So the hypotenuse is the square root of the opposite side squared plus the adjacent side squared. Let's go ahead and try that out. So I know that the opposite side is 12 squared and the adjacent side is 5 squared. Well, the adjacent side is 5 and the opposite side is 12. So then we have the square root of 12 squared plus 5 squared. 12 squared is 144, and 5 squared is 25. So we have the square root of 144 plus 25, which is the square root of 169. So that means that our hypotenuse is plus or minus 13, but we don't use minus when we're working with lengths, so our hypotenuse is positive 13. All right. So we have a hypotenuse of 13. Given that, go ahead and try to find, since we know the hypotenuse is 13, 12, and 5, that's not drawn to scale, okay? So this is our triangle we're working with, all right? We have a hypotenuse of 13, an opposite side of 12, and an adjacent side of 5. Try and find sine of theta, all right? The sine is always opposite, so 12 over hypotenuse, which is 13. So the sine of theta is just 12/13. All right, now go ahead and try and find cosine of theta. All right, so the cosine of theta is adjacent. Adjacent is 5 over hypotenuse, which is 13. So the cosine of theta we leave as 5/13. All right, now go ahead and try and find the tangent of theta. The tangent of theta is just the opposite over the adjacent. So we have the opposite of 12, and the adjacent's 5, so we're left with 12/5. All right, now go ahead and find the cosecant of theta. You should have gotten that the cosecant of theta was 13/12. One way is by using the definition here. The other way is by knowing that it's 1 over the secant, or sorry, 1 over the sine. So instead of 12/13, so you get 13/12. All right, how about secant of theta? So for secant of theta, right, cosine is 5/13, so secant is 13/5. All right, and cotangent. So for cotangent, you have the adjacent over the opposite, right? And we know that tangent was opposite over adjacent, 12/5. So that means we have 5/12 as the cotangent of theta. So that's an introduction to your 6 basic trig functions, which is like the main portion of 9.1. So nicely done. For those of you that are concerned, like if you didn't do too hot on these questions, maybe you like are just like stuck on this stuff, that's okay. Keep in mind that the what you get on these questions here are still just complete versus incomplete. Did you do them or did you not? So if you like bombed this, you're not going to get a 0 out of 6 just because you didn't know something that you're learning. All right, so I want to make sure that's really clear that as long as you do these problems, you're going to get credit for them. All right, even if you get them wrong. That's how I've been grading all trimester. That doesn't change just because it's extra credit. All right, so as long as you do the problems and as long as you're trying out this stuff, you get credit for it. All right, that being said, I still want you to actually try, because when it comes to your test, all right, your extra credit test, you're going to have to do well. So this is at least the introduction to some of the basics of this. So that's all I got for you. Thanks for watching.